It's time for second grade math. If you're a second grader, this is the math video for you. You look excited, like you're ready to learn, and you know I'm excited. This dog is excited. You know, he's on the second grade math video for some reason, but we can't look at this dog forever because there's a lot to cover. So let's go ahead and jump right into the math fun. The first thing we're going to learn about is double-digit addition. Double-digit addition. Now, you already know basic addition and how it works, which is awesome, but we're going to practice adding larger numbers. Let's say there's this kid named Travis. Hi, Travis. Travis collects these. What are these called? Marbles. Travis collects marbles. Travis had a lot of marbles. He had 54 marbles. But today's his birthday, and someone just gave him 21 more marbles. Wow! And now he wants to know, how many marbles do I have? I had 54, and now I have 21 more that are in my collection. How many marbles do I have? That's the question that Travis has. What's 54 plus 21? Now here's the deal, Travis. You could count each of the marbles one by one to figure out exactly how many you have now. But that would take a long time. Look at all of these marbles. There has to be a better way. In fact, there is. There's a way that is super fast and super fun. We can add 54 and 21 together by doing a fun trick. We'll turn these big numbers that are difficult to add on their own into smaller numbers. What you will do is you will add the numbers to the right here, which are the ones. To make it easier, we are going to block the 10 spot for right now with this nifty blue rectangle. Suddenly, this huge big addition problem has turned into a simple, fun addition game. So we add the right spot, the ones spot together. What is 4 plus 1? Yes, 4 plus 1 equals 5. So we'll write 5 under the 4 and the 1. Awesome job. We're halfway done already. Next, we will add the 10s together. The 10 spot is to the left. The two numbers in the 10 spot are the 5 and 2. To make it easier, we are going to block the 1 spot with another blue rectangle because we already added the 1 spot up. What is 5 plus 2? 5 plus 2 equals 7. So we will write 7 under the 5 and the 2. So what is our answer? What is 54 plus 21? You can see it right here. 75. 54 plus 21 equals 75. The answer to an addition problem is called the sum. Our sum is 75. It's simple. With double-digit addition, you add the right side, the ones, together first. Let's figure out what 30 plus 12 is. First, what is 0 plus 2? Yes, 0 plus 2 is 2. So we'll write a 2 under the right side, the ones side. We've almost arrived at our answer already. Then we add the left side, the 10s, to get our answer. What is 1 plus 3? Yep, 1 plus 3 equals 4. So the sum of this addition problem is 42. 30 plus 12 equals 42. Let's try a different type of addition problem. 33 plus 6. This is an interesting one because 33 is a double-digit number, but the number 6 is a single-digit number. But we use the same fun trick as before. First, we add up the ones. What is 3 plus 6? 3 plus 6 equals 9. So we write 9 here under the ones. Next, let's add up the tens, but there is only one number in the 10 spot, so what do you get if you add nothing to 3? You get 3. So what is our sum? Yes, our sum is 39. How are we doing? Double-digit addition is pretty cool, isn't it? Now we are going to talk about something special, really special. Special like seeing an owlet, a little baby owl looking at you, looking at your eyes, you know. Oh, so cute, so cute, so special. So what is this special thing we are about to learn? Well, sometimes something sneaky happens. Let's show you. Let's say we are adding 17 plus 15. We of course start with the right side, adding up the ones first. So what is 7 plus 5? Do you know? 7 plus 5. Yeah, 7 plus 5 equals 12. That's right. But there's only enough room for one digit under the 7 and the 5. So what do? Well, we do a super cool move called regrouping. Regrouping is awesome. Remember, the sum of our ones column is 12. 7 plus 5 equals 12. So we have to regroup the number 12. But what does that mean? What does regrouping even do? Well, regrouping splits the digits and puts them in different places. Now that might sound weird, but we're going to show you how it works. It's super simple and fun. Regrouping the number 12 is easy. All we do is split the digits, putting the 2 under the ones and carrying the 1 with the tens up here. That's it. Then we add up the tens. What is 1 plus 1 plus 1? Yeah, 1 plus 1 plus 1 equals 3. So we write 3 under the tens. And now we have our answer. 17 plus 15 equals 32. 32 is our sum. Remember, regrouping is only used when there is a double-digit number, but there is only space for one digit, like our example, 7 plus 5 equals 12. But there wasn't enough room for both numbers, so we keep the 2 under the ones and carry the 1 to the tens. Hey, let's practice by playing a game. The game is called Do We Need to Regroup? This is probably the most exciting double-digit addition game ever. Hosted by our very own Mr. Whiskers. Thanks for helping us out. You're not gonna help us out. Okay. Okay, now this is embarrassing. Okay. Fine. Okay. Alright. That's okay. That's alright. It's alright. Okay? It's okay. Alright, well, we are going to look at double-digit addition problems, and you are going to let us know, do we need to regroup? Here is our first problem, 32 plus 19. You already know the question. When we add 32 and 19, do we need to regroup? Yes, because 2 plus 9 equals 11, which is a double-digit number. Remember, the first step we take is adding up the ones. But if the sum is a double-digit number, that means we need to regroup. Great job. Let's go ahead and finish the problem. When we regroup, we split the digits. So the first one gets carried, and the second number, in this case, also the number 1, stays down under the ones. Then we just add up the tens. What is 1 plus 3 plus 1? 5. So, 32 plus 19 equals 51. And yes, we did have to regroup. Here is our second one. 56 plus 22. This is the question. When we add 56 and 22, do we need to regroup? No, because 6 plus 2 equals 8, and 8 is a single-digit number that can fit under the ones. Remember, the first step we take is adding up the ones, and since the sum is a single-digit number already, we do not need to regroup. Fantastic. Let's go ahead and finish the problem. So when we added up the ones, our sum was 8. We'll put the 8 under the ones. Then we just add up the tens. What is 5 plus 2? 7. And we have our answer. 56 plus 22 equals 78. And no, we did not have to regroup. Here is our next one, 34 plus 25. This is the question. When we add 34 and 25, do we need to regroup? The answer is no, because 4 plus 5 equals 9, and 9 is a single-digit number that can fit under the ones. Remember, the first step we take is adding up the ones, and since the sum is a single-digit number already, we do not need to regroup. Well done. Let's go ahead and finish the problem just for fun. So when we added up the ones, our sum was 9. We'll put the 9 under the ones. Then we just add up the tens. What is 3 plus 2? 5. And we have our answer. 34 plus 25 equals 59. And no, we did not have to regroup. This is our last one. You have been doing great. 43 plus 37. You already know the question. When we add 43 and 37, do we need to regroup? Yes, because 3 plus 7 equals 10, which is a double-digit number. Remember, the first step we take is adding up the ones, but if the sum is a double-digit number, that means we need to regroup. Wonderful. Let's go ahead and finish the problem. When we regroup, we split the digits. So the number 1 gets carried, and the second number, in this case, the number 0, stays down under the ones. Then we just add up the tens. What is 1 plus 4 plus 3? 8. So 43 plus 37 equals 80. And yes, we did have to regroup. Amazing job learning double-digit addition. That was really awesome, especially with regrouping. I'm a regrouping fan, I guess. Well, the fun is going to continue because we are going double-digit again, this time with subtraction. You already know basic subtraction, but right now we're going to subtract larger numbers, double-digit numbers. Oh, this dog is still on the computer. Okay, you can hang out with us and learn double-digit subtraction too. Why not? Why not? Let's say we have a lot of blueberries. For some reason, they're just hanging out on a wooden table. We need to wash them and put them in a bowl. Let's pretend that when we were putting them in the bowl, we counted them and found that we had 66 blueberries. That's a lot of blueberries. You and your friends are hungry and blueberries are super yummy, right? So you and your friends eat 54 blueberries. That's right. These are some big numbers, some double-digit numbers. To find out how many blueberries we have left, we simply subtract 54 from 66. Let's look at how that's done. Here is our subtraction problem again, 66 minus 54. With double-digit subtraction, all we do is break this big problem up into two little problems. First, we will subtract the right column, the ones. to make it a little easier, we are going to cover the tens column with this blue rectangle. Suddenly, this big subtraction problem is a really easy one. What is 6 minus 4? Do you know? Yes, 6 minus 4 equals 2. So we put the number 2 under the ones column, the right side. Great job. We are halfway to our answer. Next, we will subtract the left column, the tens. And this time we're going to cover up the ones column to make it a little easier. So, what is 6 minus 5? 6 minus 5. 6 minus 5 equals 1. We will write 1 under the tens, the left column. And just like that, we have our answer. The difference is 12. There are now just 12 blueberries. All right, let's do another one. How about 87 minus 53? This should be fun. First, subtract the right side, the ones. What is 7 minus 3? Yes, 4. So we will write 4 under the ones. Simple. Next, we just subtract the left side, the tens. What is 8 minus 5? Yes, 3. So we write 3 under the tens column. And we have our answer. The difference is 34. Double-digit subtraction is simple. First, subtract the right, the ones. Next, subtract the left, the tens. Then you have your answer, which is also called the difference. Now, there is something interesting that can happen when you subtract larger numbers. Here, we'll show you. Say we have this subtraction problem, 22 minus 17. Let's follow the process. So first we subtract the ones. What is 2 minus 7? Well, here's that interesting thing we mentioned to you. Say I have 2 carrots, and I need to give 7 carrots away. That's a problem. It's hard to give away more than you have. So what do? Well, we do a special trick. No, not this kind of trick. Wow, he is really high up there. No, not this kind of trick either, alright? It's a math trick, okay? It's a math trick. This is a subtraction video after all. The trick is called regrouping. Can you say that? Regrouping. Yeah, regrouping. When you are subtracting a column and the bottom number is bigger than the top number, that means you need to regroup. Just like in this example, because it is hard to take away more than you have, and 7 is bigger than 2, so we need to regroup. So how does this regrouping trick work? It's really easy. All you do is borrow 1 from the tens column. What is 2 minus 1? Yeah, 1. So this number in the tens column becomes a 1. And that 1 that we borrowed from the tens, it goes to the ones. It gets placed on this 2 in the ones column. And now the ones column is 12 minus 7. Now we just have to follow our subtraction game plan. We subtract the right column, the ones first. What is 12 minus 7? Yes, 12 minus 7 equals 5. So we write the number 5 under the ones column. Then, of course, we have to subtract the tens, but regrouping made this super easy. What is 1 minus 1? Yes, 1 minus 1 equals 0. So our answer is simply 5. 5 is our difference. Remember, when you are subtracting a column and the bottom number is bigger than the top number, that means you need to regroup. And with subtraction, regrouping means borrowing. In double-digit subtraction, regrouping is when you borrow 1 from the tens column. Let's try one more double-digit subtraction problem and see if we need to use the special regrouping trick. 43 minus 25. This is going to be awesome. Remember, the first thing we do is subtract the right column, the ones. But, 5, the bottom digit, is bigger than 3, the top digit. Time to regroup. So we borrow 1 from the tens column. What is 4 minus 1? Yes, 3. Then we put that 1 in front of the 3 in the ones column, making it the number 13. Then we just follow the process, subtracting the ones column first. What is 13 minus 5? What is 13 minus 5? Yep. It is 8, so we will write 8 under the ones column. Now it's time to subtract the tens. What is 3 minus 2? What is 3 minus 2? You got it. 3 minus 2 equals 1. So we put the number 1 under the tens column, and we have our answer. 43 minus 25 equals 18. 18 is the difference. We've learned a lot, but we need to make sure we are able to remember everything. Here's an idea. There's this guy, Mummy, who doesn't know how to do double-digit subtraction, okay? So we are going to do a double-digit subtraction review by teaching Mummy. It's simple and it's fun, Mummy. You'll love it. So, Mummy, subtraction is when you take numbers away. Sometimes subtraction problems can have little numbers, or other times subtraction problems can have bigger numbers, double-digit numbers. Here's how it works, Mummy. First, subtract the right column, the ones. Next, you subtract the left column, the tens. Then you have your answer, which is called the difference. Sometimes the bottom digit is bigger than the top digit in the ones column. This is something to get excited about, Mummy. It means you can use a special trick called regrouping. You just borrow 1 from the tens column and move it to the ones column. Then just follow the plan. Awesome job learning about double-digit subtraction. You did great! You might have noticed I talked about ones and tens when we were learning double-digit math. Those are place values. Place values. Let's take some time right now to learn more about place values. But to do that, we need to learn this word right here. Digits. Digits. So, what are digits? Digits are the parts of a number. Like, look at the number 920. There are 3 parts, or digits, in this number. The number 920 has 3 digits. Remember, digits are the parts of a number. Pretty simple. Let's look at the number 74. There are 2 parts, or digits, in the number 74. The number 74 has 2 digits. Remember, digits are the parts of a number. Super simple, super easy. And finally, let's look at the number 6. How many digits are in the number 6? Remember, we're just looking at the parts of the number. How many digits? Yeah, just 1 digit. There's only 1 part or digit to this number. It's just 6. Great job! Remember, digits are the parts of a number. Okay, so this is awesome. Here is where place values come in. The place value is how much a digit is worth based on where it is. In other words, where a digit is in the number tells us how much it is worth. So what are the place values we're going to be looking at today? What are the different values of the places where the digits will be? Well, the digits will either be in the ones spot, the tens spot, the hundreds spot, or the thousands spot. Alright, let's use the place values. Okay, so here are the place values and where they are for the different digits. This first spot is the ones spot. That's where the ones go. This second spot is the tens spot. It's where the tens go. This third spot is the hundred spot. It is where the hundreds go. And finally, here is the thousands spot. It is where the thousands go. Now the place values can go higher than this, but these are the only place values we're going to be learning about today. Alright, so our first example is the number 4,000. The number 4,000. Alright, well I'm going to need your help. Which digit is in the ones spot? You can see it right there. Which digit is in the ones spot? Yeah! 0! Great job! Alright, how about helping us figure out the tens? Which digit is in the tens spot? Yeah! 0! Good job! All you have to do is look where the arrow is pointing. The 10 spot is a 0. Alright, how about the hundreds spot? Which digit is in the hundreds spot? You see? Yeah, the same answer, 0. Good job, good job. Okay, and which digit is in the thousands spot? Which digit is in the thousands spot? Yeah! 4! Awesome! The number 4 is in the thousands spot. There are 4 thousands in the number 4,000. Alright, our next example is the number 508. Okay, I'm gonna need your help again. Which digit is in the ones spot? You can look at the place values for a clue. You can see the arrow. Which digit is in the one spot? Yeah, 8. Good job. Okay, which digit is in the tens spot? Which digit is in the 10 spot? Yeah, 0. Good job. Alright, which digit is in the hundreds spot? Can you see that? Which number is in the hundreds spot? Yeah, 5. Good job. Okay, now this might seem a little tricky. Which digit is in the thousands spot? Which digit is in the thousands spot? Wait a second, there isn't even a digit there. It's only 508. There are no thousands. So the digit would be nothing or 0. 0 and nothing, it has the same value. So there's nothing that's in the thousands spot. It's only 508. There are no thousands. You are doing a phenomenal job. Okay, now you're going to be able to give it a try without any help or any clues. And you've learned so much. I think you can do it. I think you can do it. You're going to do awesome. Okay, you're ready. Here's the number. 8,763. 8,763. We're going to name the place values, and you let us know which digit is in which one. Okay, which digit is in the one spot? Which digit is in the one spot? The number's 8,763. Which one? Yeah, 3. 3 is in the 1 spot. Remember, this is the 1 spot. Good job! Okay, what's in the 10 spot? Which digit is in the 10 spot? 6. 6 is in the 10 spot. Good job! Yeah, you can see right here is where the 10 spot is. Wow, you're getting the hang of it. Okay, which digit is in the 100 spot? Do you know which one? Which digit is in the 100 spot? 7. Way to go! Yes, 7 is in the 100 spot, and you can see right here is that 100 spot. Yeah! 7 is in the 100 spot. Good job! Okay, here's the last one. Which digit is in the 1000 spot? Which digit is in the thousands spot? 8. Yes, good job. 8 is in the thousands spot. And you can see right here is where that thousands spot is, just before that comma. Isn't that awesome? Wow, you've learned so much. To review, digits are the parts of a number. The place value is how much a digit is worth based on where it is. These are the place values we learned today, the ones, tens, hundreds, and thousands. In this example, there are 3 ones, there are 6 tens, which is 60, there are 7 hundreds, which is 700, and there's 8 thousands. So the number read out is 8,763. It's so nice going for a stroll and just thinking about those place values. Oh, I love the ones and the tens and the hundreds and the thousands. Knowing where a digit is tells us what the value is, which is great. Amazing job learning about place values. That was fun. Plus, I think this dog is still watching and learning with us, which is nice. You know, it's nice. We're going to switch topics now and talk about something really cool. Multiplication. Multiplication. And we should start with this question. What is multiplication? Well, multiplication is when you have a number a certain number of times. For example, a standard bike has 2 wheels, but if there are 2 bikes, then you have the number 2 times. In other words, 2 times 2. That's multiplication. This x tells us we're multiplying. The number 2 times is the same as 2 plus 2. It's the number 2 twice. How many wheels are there in all? What's 2 times 2? Yeah, 4. 2 times 2 equals 4. There are 4 wheels in all. You know, a motorcycle has 2 wheels also. Whoa, here are 3 motorcycles. To find the total number of wheels, we have the number 2 3 times. 2 times 3. 2 times 3 is the same as 2 plus 2 plus 2. It's the number 2 3 times. What is 2 times 3? Yeah, 6. There are 6 wheels in all. 2 times 3 equals 6. There are a total of 6 wheels when you have 3 motorcycles. Great job. Cookies. Yeah, let's practice multiplication with cookies next. Let's say a store sells boxes of cookies. There are 3 cookies in each box, and someone buys 3 of these boxes of cookies to enjoy with some friends. Now, to figure out how many cookies there are in all, you would multiply the 3 cookies times 3, because there are 3 boxes. 3 times 3. This is the same as 3 plus 3 plus 3. It's the number 3 times. What is 3 times 3? 9. Awesome! 3 times 3 equals 9. That means there are 9 cookies in all. 3 cookies 3 times means there are 9 cookies. We could even count the cookies to double check. 3 cookies 3 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 times 3 equals 9. I don't know if I've mentioned this in any of my videos, but I love basketball. It's my favorite sport. I was obsessed with basketball as a kid and collected basketball cards. Actually, I still have my basketball cards. I keep them in my office and still look at them from time to time. They're really cool. Now, why am I sharing this? Well, when you collect cards, you're used to using multiplication. Let's say a new series of basketball cards has 6 cards in every pack. Every pack has 6 cards. And I have enough money to buy 3 of these packs. To find out how many cards I'm getting in all, we have to multiply 6 times 3. It's the number 6 3 times. This is the same as 6 plus 6 plus 6. It's the number 6 multiplied times 3. What is 6 times 3? Yeah, 18. Great! 6 times 3 equals 18. I'm getting a total of 18 cards. We can just double check that real quick. 6 times 3 means we have the number 6 3 times, which is the same as 6 plus 6 plus 6. 6 plus 6 equals 12. Yeah. And 12 plus one more 6 is 18. Yeah. 6 times 3 equals 18. Let's try another one. What is 8 times 1? What is 8 times 1? Yeah, 8. 8 times 1 equals 8. Now, why is that? Well, if you have the number 8 just one time, you just have 8. Actually, any time you multiply a number times 1, the answer is that number. Going back to bikes, you know that a bike has 2 wheels. If you have one bike, to find the total number of wheels using multiplication, you could multiply 2 times 1. 2 wheels, once. The number 2, just one time. And what's 2 times 1? Yeah, 2. 2 times 1 equals 2. If you multiply any number times 1, the answer is that number. For example, 9 times 1 equals 9. It's 9 just one time. 12 times 1 equals 12. It's the number 12 one time. 100 times 1 equals what? 100. It's 100 just one time. Great. Let's give this one a shot. 7 times 0. What do you think 7 times 0 is? Yeah, 0. But why is that? Well, if you have a number 0 times, you have 0. 7 times 0 equals 0. 7 times 0 means the number 7 0 times. The answer is 0. Whenever you multiply a number times 0, the answer is 0. 1 times 0 equals 0. It's the number 1 0 times. 5 times 0 equals 0. It's the number 5 0 times. 10 times 0 equals 0. What is 1 million times 0? You got it, 0. Awesome job. Aw, look at these puppies. Come over here, puppies. We're going to practice more multiplication. Come on. Hey, let's try this one. What is 4 times 2? What is 4 times 2? Yeah, 8. 4 times 2 equals 8. Great job. 4 times 2 is the number 4 2 times. This is the same as 4 plus 4. It's 2 4s, and 2 4s equals 8. 4 times 2 equals 8. Okay, let's try 5 times 3. What is 5 times 3? Yes, 15. 5 times 3 equals 15. Sweet! 5 times 3 is the number 5 3 times. This is the same as 5 plus 5 plus 5. It's 3 5s. 5 plus 5 equals 10, plus another 5 is 15. 5 times 3 equals 15. Next, let's try 1 times 4. What is 1 times 4? 4. Very cool. 1 times 4 equals 4. If you have the number 1, 4 times, you have 4. You might have picked up on this already, but with multiplication, the order of what you are multiplying doesn't matter. The answer is the same. 4 times 1 equals 4. 1 times 4 equals 4. If you flip the 4 and the 1, the answer is the same. The answer is 4. I'll show you with pizzas, okay? Let's say there's going to be a big party, right? And a pizza place has a 4 pizza deal. It's a special deal that gets you 4 whole pizzas at a lower price per pizza. You get 1 4 pizza deal. It's 4 times 1. The number 4 once. 4 times 1 equals 4. So you have 4 pizzas. Now, if you flip the order and switch the 1 and 4, the answer is the same. See, this is the same as if you multiplied 1 pizza 4 times. That would be 1 times 4 equals 4. Both work. You can flip these numbers in multiplication, and the answer stays the same. Oh, it's question time. It's question time. I have a question for you. What is the answer to a multiplication problem called? What is the answer to a multiplication problem called? Yeah, the product. The answer to a multiplication problem is called the product. For example, 5 times 2 equals 10. 10 is the answer, so it's called the product. 0 times 6 equals 0. 0 is the answer, so 0 is the product. The answer to a multiplication problem is called the product. Let's go ahead and look at a few more. What is 3 times 4? What is 3 times 4? Yeah, 12. 3 times 4 equals 12. Phenomenal job! And as we just learned, 12 is the product. It's the answer to this multiplication problem. 3 times 4 means we have the number 3 4 times. It's the same as 3 plus 3 plus 3 plus 3. The number 3 4 times. 3 plus 3 equals 6. So each of these pairs equals 6. And what's 6 plus 6? Yeah, 12. That means 3 times 4 equals 12. Wow, we're in Egypt. That's pretty cool. That's pretty cool. Let's try 5 times 6. What is 5 times 6? What is 5 times 6? 30. Very cool. 5 times 6 equals 30. This is a big answer, isn't it? 5 times 6 is the number 5 6 times. To double check this, we can count by 5s. 5, 10, 15, 20, 25, 30. 5 times 6 equals 30. Great job! 30 is the product, the answer to this multiplication problem. Okay, here's the last one. What is 10 times 7? What is 10 times 7? Yeah, 70. Awesome! 10 times 7 equals 70. This can be illustrated using dimes because dimes are worth 10 cents. 10 times 7 means the number 10 7 times. Each dime is worth 10 cents, and there are 7 of them here. 10 times 7. To check our answer, we can count by tens. 10, 20, 30, 40, 50, 60, 70. 10 times 7 equals 70. 70 is the product. Wow, you did an incredible job learning about multiplication. I'm so proud of you. Next time you come across multiplication, you can get super excited just like this owl because you get it. You know how it works. Keep building up your skills. Multiplication is really cool, and so are you. I love it. That was a blast. If you need to stretch real quick, feel free. Yeah. We've learned so much already, and there's still more fun ahead. All right. Next, let's learn about the opposite of multiplication, which is division. That's right. Division. First, we need to find out what is division. What is division? Well, division is when we split a number up by a certain number. Let's say there are 4 apples. Michael and Liam want to split the apples, and they want to make sure it's fair. There are 4 apples, and we are dividing the apples into 2 groups. One for Michael and one for Liam. 4 divided by 2. This symbol right here is the division sign. It shows us we're dividing. What is 4 divided by 2? Yeah, 2. That's right. 4 divided by 2 equals 2. If Michael and Liam are splitting these 4 apples, they each get 2. Check out this one. Let's say there are 6 bottles of water and there are 6 kids playing outside. That would be 6 divided by 6. If we split the 6 bottles by 6, how many water bottles does each kid get? 1. Great job. 6 divided by 6 equals 1. Everyone gets 1 water bottle. All right, next, let's practice division with school supplies. Let's say there are 9 brand new pencils that 3 students are going to split. 9 divided by 3. We're dividing the 9 pencils between the 3 students so that the students each get the same number of pencils. When we divide 9 by 3, how many pencils does each student get? Yes, 3. Great job. That means 9 divided by 3 equals 3. If you split 9 into equal groups of 3, there are 3 in each group. 9 divided by 3 equals 3. Awesome job. Before we practice more division, I want to ask you a quick question. What is the answer to a division problem called? What is the answer to a division problem called? The quotient. Yeah, the quotient. That's a cool word. Let's say that together. The quotient. Right. Can we say it one more time, just a little louder? The quotient. Yeah, the quotient. Okay, so we practiced 4 divided by 2, which equals 2. 2 is the quotient. We did 6 divided by 6, which equals 1. 1 is the quotient for that problem. And we just did 9 divided by 3, which equals 3. That means 3 is the quotient for that problem. The quotient is the answer to a division problem. And don't worry, Crab, we're going, okay? We have more division to do. Oh my goodness, it's somebody's birthday! Speaking of birthdays, here's a man celebrating his birthday with just 1 candle. I'm not sure what he's saying, but I like to think he's saying, "I put 1 candle on my cake." And she responds, "That's great. That's great." We're going to be dealing with more than 1 candle, though. In fact, imagine we have 7 candles. 7 of them. Now, in the other division examples, we divided a number into multiple groups. But in this example, we are only going to divide 7 by 1, because all of the candles are going on the same cake. 7 divided by 1. And the answer is super simple. How many candles does each group have? Well, there's just 1 group, and all 7 candles are on it, so the answer is 7. Yes, 7 divided by 1 equals 7. 7 is the quotient. Anytime you divide a number by 1, the quotient is that number because all of it is going into just one group. For example, 9 divided by 1 equals 9. It's 9 just getting put into one group. 40 divided by 1 equals 40. It's 40 getting divided into just one group. 1,000 divided by 1 equals 1,000. It's 1,000 divided into just one group. When you divide a number by 1, it's super simple. The quotient is that number. Whoa, look at these two bears. These two bears are going to share some fish, okay? They're going to evenly divide some fish, okay? Whoa, bears. You both are friends. You both need to share these fish, okay? Evenly. We're going to divide them up. So there are a total of 10 fish, and we are dividing the 10 fish into two groups, one for each bear. 10 divided by 2. The quotient, the answer to the division problem, will tell us how many fish each bear gets. What is 10 divided by 2? Yeah, 5. Great. 10 divided by 2 equals 5. And you can see each bear gets 1, 2, 3, 4, 5 fish. 10 divided by 2 equals 5. Awesome job. Aw, hello doggies. Are any of you hungry? I'm asking because, well, I have good news for the 4 of you. We have dog biscuits for you to share. We just want to divide them evenly so each of you gets the same amount. We have 12 dog biscuits here, 12 of them, and there are 4 dogs. 12 divided by 4. We have to divide or split up the 12 dog biscuits into 4 equal groups. 12 divided by 4 will tell us how many dog biscuits each dog will receive. What is 12 divided by 4? 3. Great job! 12 divided by 4 equals 3. Each dog will get 3 dog biscuits. 12 divided by 4 equals 3. 3 is the quotient. You are doing an incredible job. Let's try this one next. How many people do you see here? 5. There are 5 people who have been playing outside and are going to take a quick snack break. Thankfully, they brought strawberries. They have 20 strawberries in all and want to divide them amongst each other. This will be fun. So there are 20 strawberries in all, and we are dividing them into 5 groups, one for each person. 20 divided by 5. What is 20 divided by 5? Yeah, 4. Awesome! 20 divided by 5 equals 4. That means each person gets 4 strawberries. 20 divided by 5 equals 4. 4 is the quotient. Great! Hey, I think it's time for a division fact. It's division fact time! When you have a division problem, the total number is called the dividend. The number of groups you are splitting it up into is called the divisor. And the answer, as we've already talked about, is called the quotient. Now, a cool thing about division is you can switch the divisor and the quotient, and the division problem remains true. For example, 8 divided by 4 equals 2, but also 8 divided by 2 equals 4. Interesting. The divisor and the quotient can be switched, and the division problem remains true. I'll show you with bananas. Bananas are so tasty! We have 8 bananas here. 8 divided by 4 equals 2. Dividing the 8 bananas into 4 groups means each group has, 2 bananas in it. Cool. Now, if we flip the 4, which is the divisor, and the 2, which is the quotient, it remains true. So 8 divided by 2 equals 4. If we divide the 8 bananas into 2 groups, we see there are 4 bananas in each group. That's pretty awesome. And speaking of awesome, the next example is from the world of tennis. Have you ever played tennis before? Okay. I enjoy tennis. It's a fun sport. Let's say there are a total of 16 tennis balls, and 2 tennis players want to split them up. 16 divided by 2. 16 divided by 2 will tell us how many tennis balls each player will get. What is 16 divided by 2? Yeah, 8. There are 8 tennis balls in each of these 2 groups. 16 divided by 2 equals 8. Okay, so 16 divided by 2 equals 8. Now remember, the total we are dividing is called the dividend. The dividend is 16. The number of groups you are splitting it into is called the divisor. The divisor in this division problem is 2. And what is the answer to a division problem called? Yeah, the quotient. Great job! The quotient in this problem is the number 8. Now, we learned that we can switch the divisor and the quotient and it remains true. Let's put that to the test with this. We'll try 16 divided by 8, which will be 2. Here are the 16 tennis balls again, but this time we'll divide them into 8 groups because the divisor is 8. In this case, 8 players are splitting the 16 tennis balls. How many are in each group? 2. 16 divided by 8 equals 2. Fantastic job. So you really can switch the divisor and the quotient and the answer remains true. That's really cool. Okay, let's look at a few final division problems. If you don't know the answer, that's all right. Division can take practice and you'll learn a cool new division fact for next time. Here's the first one. 9 divided by 9. What is 9 divided by 9? Yes, 1. 9 divided by 9 equals 1. If you have 9 and divide them into 9 groups, there is 1 in each group. 9 divided by 9 equals 1. 1 is the quotient. Great job! Here's the next one. 14 divided by 2. What is 14 divided by 2? 7. 14 divided by 2 equals 7. If you have 14 and divide it into 2 groups, each group has 7 in it. 14 divided by 2 equals 7. 7 is the quotient. Fantastic. All right, here's the last one. What is 15 divided by 3? What is 15 divided by 3? Awesome! 5! Yeah! 15 divided by 3 equals 5. If you have 15 and divide it into 3 groups, each group has 5 in it. 15 divided by 3 equals 5. 5 is the quotient. You did such an amazing job. Even if you didn't know all of these, you are well on your way to being a division master. Amazing job learning about division. Whoa! Okay, what does this beaver have to do with any of this? I'd love to get back to math if we could, okay? Great, okay, great. I think we are ready. Now we are going to learn about something related to division. Fractions. That's right. Fractions. It's fraction time. I love fractions because they make me think of pizza. Yeah, pizza. You see, a fraction is a way to show a part of a whole. And a whole pizza is usually way too big for one person to eat alone. People usually eat just a part or a fraction of a pizza. I'll show you how it works with this pizza here. The pizza is cut into 4 equal slices. That means the whole pizza is now in 4 parts. If I eat 1 slice, that means I ate 1 out of 4 slices. That's written like this: 1/4. 1/4. I ate 1/4 of the pizza. The top number shows how many pieces I ate. Just 1. And the bottom number shows how many pieces the whole pizza was cut into. 4. 1/4 is a fraction. A fraction is a way to show a part of a whole. Let's look at 1/4 again. The top number, this number 1, is called the numerator. The numerator shows how many parts you have. The bottom number, the number 4 in this case, is called the denominator. The denominator shows how many equal parts the whole is split into. And this line actually means division. The numerator is being divided by the denominator. That's a fraction. Let's look at another one. This is a fraction you might have seen before. It's called 1/2. What if I had a smaller pizza and I decided to split it right down the middle to share with a friend? It's only cut into 2 equal slices or parts. If I eat one of those slices, I've eaten 1 out of 2, which is 1/2. This top number, the 1, is the numerator. It tells us how many slices I ate. This bottom number, the 2, is the denominator. It tells us how many equal parts the whole was cut into. Uh-oh, looks like someone wants the other half. Sorry, buddy, I already promised it to someone else. Plus, pizza isn't for dogs. Yeah, maybe we can find you some dog treats, you know? What are you gonna do, right, Mr. Whiskers? Yeah, we should probably go back to talking about fractions. Okay, check this one out. This time, I'm cutting the pizza into 3 equal slices. If I eat 1 slice, that's 1 out of 3. That's called 1/3. 1/3. The top number, the numerator, is 1, because I ate 1 slice. The bottom number, the denominator, is 3, because the whole pizza was cut into 3 equal parts. I ate 1/3 of the pizza. You know what? I've had a lot of pizza here, all right? And I get it, okay? But may I please just get a carrot, okay? I need carrots. Please, carrots. Okay, I feel better. Now, you know how the top number in a fraction is called the numerator and the bottom number is called the denominator? Well, I have a trick to remember that. When I think of fractions, I think of North Dakota. You know, the state. North Dakota. ND. It helps me remember that the numerator is on top and the denominator is on the bottom. North Dakota. I hope you don't mind. You've helped me through the years with fractions. Thank you, North Dakota. The numerator is on top. The denominator is at the bottom. North Dakota, ND. That's pretty cool, you know? Okay, now that we've seen how fractions work, it's time for a game. I'm going to show you some shapes. Each one will have 2 different colors. Your job is to figure out what fraction of the shape is red, okay? Look closely at each shape, count the parts, and try to say the fraction out loud before I show you the answer. Are you ready? All right, we'll start with a simple one. What fraction of this triangle is red? What fraction of this triangle is red? Yeah, 1/2. Half of the triangle is red. Great. The numerator shows us how many parts are red. Just 1 part is red. The denominator shows us how many total parts the triangle is split into. The triangle is split into 2 equal parts. Awesome job! Okay, what fraction of this square is red? Remember to count how many pieces are red, and then how many total pieces there are. What fraction of this square is red? 3/4. 3/4 of the square is red. Tremendous! The numerator shows us how many of the parts are red. 3 of the parts are red. The denominator shows us how many total parts the square is split into. The square is split into 4 equal parts. it's split into fourths. 3 out of 4 parts are red. That means 3/4 of the square is red. Very cool. You're getting the hang of this. Fractions. Whoa, that's a big piece. That's going to make someone very happy. Oh, it's not as big now. Okay. Well, that makes sense. That makes sense. It's just not as big of a fraction as I thought it was going to be. You know what? Let's check out another one. What fraction of this circle is red? What fraction of this circle is red? Yes, 2/3. 2/3 of the circle is red. Fantastic. The numerator shows us how many of the parts are red. 2 of the parts are red. And the denominator shows us how many total parts the circle is split into. The circle is split into 3 equal parts. 2 out of 3 parts are red. That means 2/3 of the circle is red. Great job. You know what? We only have 2 more. Isn't that great, ducks? Where are you going? You're swimming away? You're not even going to give them a try? Wow, I don't know. I thought you could practice fractions too. Well, maybe next time. Okay, here's the next one. What fraction of this rectangle is red? What fraction of this rectangle is red? Yes, 4/5. 4/5 of the rectangle is red. Awesome! The numerator shows us how many of the parts are red. 4 of the pieces are red. The denominator shows us how many total parts the rectangle is split into. The rectangle is split into 5 equal parts. 4 out of 5 parts are red. That means 4/5 of the rectangle is red. Wonderful job. All right, here is the last one. I know you've got this. What fraction of this circle is red? What fraction of this circle is red? Yes, 3/8. 3/8 of the circle is red. Very cool. The numerator shows us how many of the parts are red. 3 of the parts are red. The denominator shows us how many total parts the circle is split into. The circle is split into 8 equal parts. 3 out of 8 parts are red. That means 3/8 of the circle is red. You did an amazing job learning about fractions. A fraction is a way to show a part of a whole. The top number of a fraction is called the numerator. The numerator shows how many parts you have. The bottom number of a fraction is called the denominator. The denominator shows how many equal parts the whole is split into. And this line actually means division. The numerator is being divided by the denominator. That's a fraction. And now you've got some good fraction practice under your belt. Keep up the great work. You'll be a fractions master in no time. I'm so proud of you. You did an amazing job learning about fractions. This has been an incredible math adventure, but it's almost done. There's just one more topic to learn about. Are you ready? Okay, next, we're going to learn about symmetry. Symmetry. Yeah, if you don't know what that is, that's okay. You are about to find out, like right now, all right? Look at this triangle. It's a yellow triangle with a red border. Sometimes warning signs on the road look like this. To show you how symmetry works, I'm going to place this line down the middle of this triangle. Okay, it's still one triangle, but now it has 2 sides. Do you notice anything about the 2 sides of this triangle? Both sides match each other perfectly, don't they? That's pretty neat. And that's actually what symmetry is. This line is called a line of symmetry. A line of symmetry. If you were to draw this line down the middle of this shape, both sides would match. Aw, look at this butterfly. Does this picture of a butterfly have symmetry? Yeah. If we place a line down the middle of this picture of a butterfly, you can see both sides match each other. Yes, this line is called, do you remember? A line of symmetry. Yeah, a line of symmetry. We know it's a line of symmetry because both sides match each other. Actually, butterflies are symmetrical in real life. The patterns on both of their wings are identical to each other. They match. Butterflies are symmetrical. Let's check out some of the letters and see which ones have symmetry. We can try the first letter, the letter A. Does the capital letter A have symmetry? Yeah, it does. The capital letter A has one vertical line of symmetry, right here. Now, how do we know that's a line of symmetry? Well, we look at both sides. Do both sides match? Yes, great job. Both sides match each other. And if both of those sides match, you know the capital letter A is symmetrical. It has symmetry. That's pretty cool. I like symmetry. Hey, next, how about we look at the capital letter Y? Does the capital letter Y have symmetry? What do you think? Yeah, it does. The capital letter Y has one vertical line of symmetry. You can see it right here. We know it's a line of symmetry because we look at both sides to see if they match. Do they match? You got it. Both sides match each other. Aw, best friends. I assume they match, they might be friends. When the two sides match, that tells us the capital letter Y is symmetrical. It has symmetry. Pause for a moment, even the music, okay? I need to share something with you. And no, it's not that my true dream and passion is to make cat-themed electronic dance music in honor of Mr. Whiskers, of course. It would be in honor of you, Mr. Whiskers. Let's be honest, it's actually a pretty good idea. I think people might like it. No, this is just something some people don't realize about symmetry, okay? Here it is. Lines of symmetry don't have to be vertical, meaning lines of symmetry don't have to go up and down. Lines of symmetry don't have to be vertical. Take the letter C, for example. Does the letter C have symmetry? Well, if we try a vertical line of symmetry, it would seem like the answer is no. These sides don't match. But wait, if we try a horizontal line of symmetry, do both sides match? Yeah, they sure do. So does the letter C have symmetry? Yes, it does. That means the letter C is symmetrical. Oh wow, here are more butterflies. They are symmetrical. They have symmetry. But I don't think they know that. They go about their whole lives, and I don't think they ever figure that out. Wow. Someone should tell them, right? I don't know. Okay, let's try the letter L. Does the capital letter L have symmetry? Oh, this is going to be fun. Let's check with a vertical line first. Then we can just look at both sides. Do they match? Yeah, they don't match. This is not a line of symmetry. Hey, that's okay. Let's check with a horizontal line, all right? Do both sides match? You're right, they don't. What? No symmetry. Oh. Okay, wait, what's Rover doing on the screen? And what's with the sad music? It's okay that the capital letter L doesn't have symmetry. It's fine. We don't have to be sad. Rover, I promise you, you don't have to be sad. Look, if something doesn't have symmetry, it's this special thing called asymmetrical. Asymmetrical, that's a long word. Asymmetrical. If a letter, picture, or shape has no symmetry, it's asymmetrical. Let's look back on the capital letter L. Remember, the capital letter L has no symmetry. We tried to see if it had a vertical line of symmetry, but these sides don't match. If the sides don't match, you have no symmetry there. Then we tried to see if it had a horizontal line of symmetry, but again, the sides did not match, so there is no horizontal line of symmetry either. The capital letter L has no symmetry. That means the capital letter L is asymmetrical. Asymmetrical means it does not have symmetry. There are other letters that are asymmetrical too. Look at the capital letter R. Let's try a vertical line of symmetry first. Do these sides match? You've got it, they don't match. Wait, how about a horizontal line of symmetry? Do these sides match? Yeah, they don't match either. The capital letter R is asymmetrical. Wait, how about a lowercase r? Can you tell just by looking at it? Is a lowercase r symmetrical or asymmetrical? A lowercase r is asymmetrical too. When you're looking for symmetry, you are looking to see if the sides will match. The lowercase letter r is asymmetrical because none of the sides match. If you try a vertical line of symmetry, these sides don't match, do they? And if you try a horizontal line of symmetry, these sides don't match either. Aha! A treasure map! Actually, this is just a regular map that looks really old. I tried to find footage of a treasure map that has our last letter, the letter X, on it. Okay. But, you know, they have to keep the treasure maps secret. Maybe that's why I can't find that, okay? But the letter X is the last letter we're going to look at. I'm so excited because you are quickly becoming a symmetry expert, okay? So let's look at the letter X together. Now, just by looking at it, do you think it's symmetrical? Is the letter X symmetrical? Yes, it is. We can try a vertical line of symmetry first. Do both sides match? Yeah, they match. But here's the cool thing. We can try a horizontal line of symmetry too. Do both sides match? They do! That means the letter X has 2 lines of symmetry. Wow, that's pretty neat. Be warned, pirates. Some pictures, letters, and shapes have more than 1 line of symmetry. Okay, let's tie all of this together. When you are looking for symmetry, look for sides that match. The line down the middle that shows symmetry is called a line of symmetry. A line of symmetry. If it has symmetry, it is symmetrical. If it doesn't, it is asymmetrical. And if it is symmetrical, it might have more than 1 line of symmetry. So keep that in mind. You did such a phenomenal job. Have fun looking for symmetry all around you, looking for sides that match. That's symmetry. And you know what? You did it! You learned a ton of 2nd grade math today. I'm so proud of you. You worked hard, had fun, and did an amazing job. I think you are a math superstar. Wow, congrats on making it all the way to the end of the video. Oh my goodness. I hope you had a ton of fun. If you enjoyed this and haven't yet, be sure to subscribe to my channel. I have so many learning videos to explore. I want to give a special thank you to my patrons. Your support means the world to me. And thank you for watching. You are so awesome, and I can't wait to see you next video.